Hello and welcome to Brainwave. Today we're going to be discussing the fundamentals of atoms. So what are atoms? The name atom comes from the Greek word atomos, which means that which cannot be cut or divided. While the name has been kept, we now know that the atom is no longer the smallest known particle, and while it can be divided, it is still defined as the smallest unit of matter that forms a chemical element. So what do they actually look like? Well, previously it was thought they looked a little bit like planets with orbiting bodies. So if we draw our planet here, and its orbiting bodies. This planet is called the nucleus, and it's surrounded by negatively charged electrons. Now, why is this model not used? Well, in this model, you can see that the electrons are travelling around the nucleus, and it looks like they've got set paths. This simply isn't true. If we think of a central nucleus here, you would see that the electrons don't actually carry set paths around the nucleus. What happens is they're actually located within orbitals, like this. These orbitals simply show where there is a good chance of finding a particular electron. If you find an electron in an orbital space, you know about its energy, but you cannot make assumptions on how it is moving. If you'd like to know more about this, we need to do a further video on S, P, D, and F electron orbitals. So, what might an atom look like in your textbook? Let's go through the basics. And let's start with the central nucleus. The nucleus is where 99.9% of the atom's mass is located, and it's made up of protons and neutrons. Only the commonest form of hydrogen has no neutrons. Okay? So protons are positively charged, and neutrons have no overall net charge. You may see in your textbook the atom is surrounded by electrons, like this. And they are ordered surrounding the electron in shells. The first shell, as you can see, can contain 2 electrons. The second shell can contain up to 8 electrons, and so on, with the third shell and so on containing up to 8 electrons. If there are more electrons than protons, the atom is said to be negatively charged. If there are more protons than electrons, the atom is positively charged. The number of neutrons is also variable, which results in isotopes, which are different forms of the same atom that vary only in the number of neutrons they possess. For example, if we look at the element hydrogen, it has 3 known isotopes: protium, deuterium, and tritium. As you can see, these 3 isotopes have the same numbers of protons, 1 proton. They have the same number of electrons, 1 electron each, but they have different numbers of neutrons, with protium having no neutrons, deuterium having 1 neutron, and tritium having 2 neutrons. The last thing I want to overview in this basic introduction to the atom are the terms atomic mass, atomic number, and mass number, which seem to confuse a lot of people. Let's overview this by looking at the element of carbon. This is what you'd see on the periodic table. So the atomic mass is the average mass of an atom, taking into account all of its naturally occurring isotopes. Carbon has an atomic mass of 12.011. The atomic number is the number of protons, and that defines the chemical element. As you can see here, carbon has an atomic number of 6. The mass number is the number of protons and neutrons. Carbon, on average, has a mass number of 12, which means 6 protons and 6 neutrons. Thank you very much for watching. If you enjoyed the video, please leave a comment down below, and please like and subscribe. Take care. Bye-bye.